With West, you can create a composite or coupled model without writing any code. A coupled model is a model comprising of two or more connected submodels. In this example, we'll create a reactive settling model by combining a reactive tank and an ideal settler. The coupled model must be connected to other blocks in a process layout. So first, add relevant interface variables by dropping input and output vector blocks. Rename the interfaces to something meaningful. And then connect the blocks. The coupled model has to be integrated into a larger process model through the usual Flux interfaces. We also have to measure certain quantities through sensors and control other quantities through manipulated variables with data type terminals, which require data type input and output blocks. To create interfaces for your coupled model, drag and drop the corresponding quantities from the submodels and make them into top-level quantities. Examples of variables you might expose to the top level are dissolved oxygen and K-law, the energy required for aerating, and especially pumping sludge from the clarifier. Similarly, we'll expose some key parameters, like the volume of the reactive zone and the horizontal surface of the clarifier. Once the layout is completed, the model can be built and added to the library. Now add the new class to a category, write a name and description, and associate it to the desired icon. Check that the new model has been incorporated into the library, and take a look at the generated code. Finally, we'll want to use the new model in the scope of a larger process model. To do this, create a new project and drag a couple of blocks. In particular, a secondary clarifier associated to the new model. Then, go to the class name in the Properties pane, expand the list, and find your new model. You can see that the model is a composite in the Model Explorer, where the clarifier block now shows two sub-elements. You can select each submodel to access additional information in the Block Details panel, and select the top-level model to view parameters and variables that were exposed using the input-output vector and data blocks.